In our previous video, we understood about the dynamic routing protocols, and practically we have seen how to configure and how does the RIP routing protocol works. And also we have seen how this authentication profiles are helpful to have a secured network, right? So in this video, let's see another dynamic routing protocol that is supported by Palo Alto Firewall, that is OSPF. Okay, so when I say we are going to see about OSPF, means we are not going to learn about OSPF here. We are going to see how to configure OSPF in the Palo Alto Firewall, because OSPF itself is a big topic, right? So that's not a part of this course content. So we are not going to, yes, of course, we'll be going through the basics of OSPF. However, as you know, OSPF itself is a big content. So as a part of, Palo Alto training, we are going to, touch about the basics of OSPF and what does OSPF is. And then we are going to see more about how does OSPF works in the Palo Alto firewall, or how to configure it and check it. All right, fine. So as you know, OSPF is the open shortest path first routing protocol. Okay, and full screen. All right. So OSPF stands for open shortest path first. It is an IGP, means it's an interior gateway protocol. So there are two types of routing protocol. One is interior gateway routing protocol, and the other one is exterior gateway routing protocol. So when we say interior gateway routing protocol, this set of this types of routing protocol will be exchanging the route information, so sharing the route informations to the neighbors that are within the autonomous system. Okay. However, if you take the exterior gateway routing protocol, the routers that part of exterior gateway routing protocol, or the working of exterior gateway routing protocol, is to share the route informations between different autonomous systems. All right. So this is the difference between IGP and EGP. So this particular routing protocol, OSPF, comes under IGP, interior gateway routing protocol, which helps to exchange the route informations within the autonomous system. Okay, it is a link state routing protocol. So when I say link state routing protocol, just consider means link state routing protocol means all the devices in the topology. Okay, all the devices in that network will be having, or will maintain, or will know the entire topology. All right. So say for example, if there are 10 routers, okay, I'm just taking for a simple example. If there are 10 network devices in the running in OSPF, okay, the routers that are running in OSPF, all the 10 routers will be aware about the entire topology, the complete topology. Okay, and just consider if there is any changes in the topologies, like if a new router joins to the network, or if the existing router went down for some reason. Okay, if there is any changes in the topology, then there will be an update that will be triggered, and all the routers will be updated with the changes that happened. Okay, so this is what link state routing protocol. It's more stable, and the main advantage is every router in this running this protocol will maintain the complete topology. Okay, next, the administrative distance. So we have discussed about administrative distance in our previous videos when we discussed about the basics of routing, right? So administrative distance for OSPF in general is 110. Okay. However, if you take specific to Palo Alto, 110 is the administrative distance for external OSPF, and if it is an internal OSPF, the administrative distance is 30. All right, fine. So it uses the multicast address 224005 as well as 224006 based on the topology. Okay, and cost is the metric that's used here. So in order to find the cost, there is a formula where 10 to the power of 8 divided by the bandwidth of the interface that we are trying to calculate the cost. Okay, so as I said, we are not going much deep to learn about OSPF. Here we are not here to learn about OSPF. We are seeing how to do OSPF in Palo Alto. So we are just going through the basics. Okay, fine. So OSPF supports both classful and classless routing. Then one of the important feature of OSPF is it supports equal cost load balancing. Then it uses the concepts of area to manage the network easily. If you compare to the other routing protocols, right, the other routing protocols is having a limitations. It's like you can have only this number of routers for specific for one particular routing protocol. Okay. However, if you take OSPF, you can have infinite number of routers in the topology. So in that case, we need some method, right? We need some method to manage it easily. So in order to manage it easily, OSPF is designed in such a way that we uses the concept known as area. Okay, so the entire topology is segregated as area, and that helps us to manage it easily. All right. So we'll see about area later. So it sends a hello packet in regular intervals of time. Okay, and this hello packet, when I say regular intervals of time, it depends on the cable or the interface it is connected, I would say. So say for example, if it is an LAN cable, I think it's every 10 seconds once it will share this hello message. And if it is serial cable, this will vary. Okay, so this hello message exchange, the hello timer, right, this depends on the cable that's connected or the interface. It is a LAN WAN serial kind of thing. And the dead timer is 4 times of hello timer, which means that, say for example, if there are two devices, all right, device A, device B, which is running in OSPF. Okay, every 10 seconds once, devices will be exchanging the hello messages. All right. If device A is sending an hello message to device B, and it will be sending an other hello message after 10 seconds, right? So if device A is sending an hello message, and if it is not getting a response for that till 40 seconds, okay, means 4 times of hello message. So hello message is 10 second once. So if it is not getting for 40 seconds, 4 into hello message, then it will consider that the other side device is down. Okay, so this is what a dead timer means. It will consider that the neighbor went down. So router ID plays an important role in OSPF. So router ID is like a name to the device. Okay, fine. So as I said, OSPF uses the concepts of area, right? So the thing is, actually the topology will be having area 0. Okay, by default there will be an area 0, or every topology that's running with OSPF will be having an area 0, and that area 0 is referred as the backbone area. Okay, all other apart from area 0, there will be multiple areas. There can be multiple areas, and all other areas are common, referred as common areas. Okay, whatever area it is, if you're creating with area 2, area 1, this is common areas. Okay, but area 0 is referred as the backbone area. Okay, so why does this area 0 is called as backbone area? Means, say for example, as per this topology, there are 3 areas, right? Area 0, area 1, and area 2. So the reason why it is called as backbone area is the communication between two different areas. You can have multiple areas, okay, that's not a matter, but the communication between different areas will be done only through the area 0. So how, irrespective of how many areas you created, all those areas will be connected to area 0. Okay, so that the communication between this area 1 and area 2 will be going through only area 0. So that it's referred as backbone area. Just consider that you're creating 2 more areas like area 3 and area 4. Okay, so if you just consider I'm putting area 3 here and area 4 here. All right, so the communication between area 3 to 4, or area from area 3 to 2, or 3 to 1, or 1 to 2, sorry, 4 to 2, 4 to 1, whatever it is, the communication between different areas is possible only through the area 0, and that's the reason we refer it as an backbone area. Okay, so any router that is placed within area 0, it is known as backbone router. Okay, and the any router within the other areas is internal router. And a router which connects, or which is part of both, other area as well as the backbone area, or the connecting two areas, right, it is referred as area border router, ABR. Okay, fine. And means we can also use OSPF to exchange different autonomous system. Okay, so in that situation, in that kind of topology or specifications, we may use a router that is connected to different autonomous system, right? So that router will refer that as an autonomous system boundary router, ASBR router, border router. Okay, fine. So that's more than enough for how to configure or how does OSPF works in Palo Alto. Okay, I'm not getting as I said earlier in the very beginning, OSPF itself is a big concept. So as per the course content, we are not going to learn about OSPF. Okay, this is one of the mandate thing, and we are just going to see how to make OSPF work in Palo Alto, or how OSPF works in Palo Alto. All right, so let's see how to configure the same in our topology in our lab. So let's take the same topology. Okay, for better understanding, let's take the same topology which we used for RIP. Okay, so we'll understand about OSPF with the same topology. Okay, we don't have multiple zones, or we don't need multiple zones to learn about OSPF. Okay, we are having only one zone, where in this zone we have two routers that is connected to Palo Alto. Now what we are going to do, as you know, first we need to configure the IP addresses, the loopback interfaces, and as for this router as well. Then we need to configure OSPF routing protocol in both the routers, and as well as we are going to configure this IP addresses and OSPF routing protocol in the virtual router of Palo Alto. Okay, so just to avoid time consuming, okay, because in the last few sessions when we discuss about default routing, or when we discuss about static and RIP, okay, every time we have gone step by step, right? So now you might be familiar with assigning IP addresses and configuring the routers part and all, right? So in order to avoid time consumption, what I did, I just made this template. Okay, so we are just going to copy and paste this template here, configuration to the router, just to avoid time. Okay, time consumption. So if you see, right, let me first of all make this little left side. I'll move this. Fine. Okay, so if you see, this is for router 1. Okay, for router 1, what configuration I need to put? First of all, I need to get into my configuration terminal mode. So for that, the command is config. Okay, so before config, I should put enable, right? Enable, then you will be putting enter, then again put config terminal, put enter. Then for this interface, fast Ethernet 0/0 means this interface, I'm going to configure the IP address 10.10.10.1 as per our topology, and it's a /24 network. I need to put no shut command, and once it's done, then I need to create a loopback interfaces with this IP address. As you know, for loopback interfaces, we don't need to put no shut because automatically it will come up. All right, so this is the routing part, means how to configure the OSPF routing in the router. All right, so if you remember last time, in order to configure RIP, we put router RIP and then we advertise the network, right? So it is similar, but there is a few changes. All right, so the syntax is router OSPF, and after that we need to put in process ID, right, and hit enter. So once you put this line, OSPF routing protocol will be enabled in the routers, Cisco routers. Okay, then we need to advertise the network that need to be passed through the OSPF, right? So I am advertising all the connected network in this router. Okay, I have 3 networks. One is this 10 network, and other 2 is my loopback interfaces. So the command is network. So this is the IP, right? 1.1.1.1. But if you see here, I put like 0.0.0.0. This is nothing but inverse of your subnet mask. Okay, so if you see the subnet mask, it mentioned as like 255.255.255.0, right? This is subnet mask. So but in OSPF, we need to define the wildcard mask. Okay, wildcard mask is nothing but a reverse or the inverse of the subnet mask. Or for easy understanding, you can put whatever value that's coming in subnet mask, you can minus it, subtract it with 255. Okay, every octet. So if I subtract 255 with this octet, it will come 0. If you put 255 minus 255, it will come 0. This octet will come 0. This octet will also come as 0. So that's the reason the wildcard mask for this particular /32 is 0.0.0.0. And following to that, I need to specify, if you remember, we talk about area, right? I need to specify which area this network to be part, right? So we are making only one, means as per this topology, right? Just to make it simple, we are not creating multiple area. It's not required, okay, because we are not learning about routing in this course. We are learning about how to configure OSPF or how to manage OSPF in Palo Alto, right? So I'm just creating one area, all right? So that is backbone area. So I'm just putting area 0, which means that I'm declaring that this network is part of backbone area. All right, as same, I need to advertise the other networks also. Okay, so this is also a /32 network, and so as it is a /32 network, this is the wildcard mask 0.0.0.0, because if you minus each and every octet with 255, then you will be getting 0.0, and I am declaring this is part of area 0. And again, if you see this 10 network, right, it's a /24 network. So as usual, I put the network address, but if you see here, it is different, right? 0.0.0.255. Okay, but if you compare this subnet mask, right, as I said, it's inverse, right? Here in subnet mask, I put as like 255 255 255.0, but when it comes to wildcard mask, as I said, put minus 255 for each octet. So when you put minus 255 for each octet, it will become 0. Second octet will also become 0. Third octet will also become 0. But fourth octet, it's already 0 only. So when you have, you cannot minus 255 from any value, right? Then you put directly 255. Okay. So, and we're telling that this is also part of area 0. So that's it. So we're just going to copy and paste it in the router. So immediately it will start to run. As same, we have created the template for router 2 as well. So I have created this interfaces IPs, means for this interface I have created 10 10 10 2. Okay, for this we created 10 10 10 1, here 10 10 2, and the loopback interfaces is 2 2 2 2 and 22 22 22 22 as per this topology. All right, as same, I have created means using this command means I'm going to, okay, this is the syntax. However, router OSPF process ID I'm taking is 1. Okay, so I put a process ID 1 because here also I put 1. So I put process ID 1 and I am advertising the networks that is connected to this router as same here. Okay, all right, so let's just get into, let me first open this router. No, and also I'll click. So this time we can do it early, a short time, because we are not going to configure each and every line by line, right? We're just going to copy and paste it as it is for a Cisco. Okay, hit enter. Fine. So first let me take router 1. Okay, so this is for router 1. I'll enlarge it. Fine. So just to validate it, just to show you that if you see show IP interface brief, so far there is no IP address configured. Show IP route, so there is no route because not even IP configured, right? So what I'm going to do, I'm going to configure this router, not step by step. As I said, I'm just going here. I already prepared the template, right? I have already prepared the template. I'm just going to copy this entire thing and paste it. Or if you feel difficult, then maybe we'll go part by part. First I'll put copy, enable and config. If you see enable, then config, it's asking whether to proceed. I'm hitting yes. Now it came to configure. So now I'm copying this portion, hitting enter. Okay, maybe if required I can put exit from that. See, this interface came up. Now I'm copying this, both the loopback interfaces, and I'll right, means in order to paste it, right, means the people from network background, you might be aware about it, but if you're learning it for the first time, you can use right click, means you are copying the content from here, right? In order to paste it in the terminal, the putty terminal, you can right click it to paste. Okay, say for example, now if you see, right, I'm using control C to copy, but when I come here, I'm not putting control V. Instead, I'll just right click the mouse. Okay, it will paste it. Fine. Now the configurations are done. Now let's verify it. If you put the command do show IP interface brief, the required IP interfaces are configured. Now let me check the route. So far we have not configured any routing in the peer or the neighbor device, right? So we may not see anything, but just I'll show you. We'll be seeing only the directly connected networks with the flag of C. Okay, but once we configure the OSPF in this router and Palo Alto, we'll be seeing every routers will be having a means all these two routers and Palo Alto will be having a routing table with the flag O. Okay, O refers to OSPF. In Palo Alto, we'll be seeing OI, means OSPF internal, as per our topology. Fine. So now the configuration part at router 1 is completed. Okay, now let me open router 2. Okay, so now I have router 2. I'll just bring this side. I'll put enable show interface brief. Okay, IP interface brief. So far there is no IP address configured. I'll enlarge it little. So far nothing is configured, right? So what I'm going to do, I'll just go to our syntax. Okay, if you see here, from means this enable we need to put. Fine. So here as well, I'm just going to copy. So once you put config, you're getting into configuration mode. Then this time I'm just copying all this 3. So now we are doing for this router. Okay, I'm just pasting with the right click. So the IPs are configured now. If you see, now all the interfaces are coming up. Okay, so now we are going to configure the router OSPF. Maybe if you want, I can show you how to, means instead of copying and pasting it, for this router I'll type and do it. Router, because in the other router we have did it, right? So OSPF router 1, this is the command to enable OSPF, and as I said, network 2.2.2.2 and wildcard mask for the same is 0.0.0.0, and we need to define it should be part of area 0. Okay, same network 22.22.22.22, as it is /32, again it is 0.0.0.0, and it is also part of area 0. And network 10.10.10.0, and as it's /24, it is 0.0.0.255, and this is to be part of area 0. So this is how we need to configure OSPF. If you see, immediately now OSPF neighborship will be formed. If you see this, we are getting an a message saying that OSPF neighborship is forming. All right, so we can also validate it. Do show IP route. I'm sorry. Do show IP route is the command to check the routing table. We see, right, last time we see only 3 directly connected networks, right? But this time if you see, 2 new routes are learnt using OSPF. I'll just show you once again from my router 1, because if you see last time when we checked from router 1, right, immediately once we configured, we have checked it, we saw only this 3 routes, which is the directly connected networks. But this time, if I put show IP route, I can see 2 more routes from router 2. Okay, that is learnt using OSPF routing protocol. It's a dynamic routing protocol. Okay, we have not manually specified as like in order to reach this you need to go to the next hop, this, that. No, we have not done anything. We just advertised the route network, and we have enabled OSPF. OSPF automatically learned the route, right? So these 2 routes are learned via OSPF. If you see 2.2.2.2 and 22.22.22.22. So if you see, it's telling 110, right? So 110 is the administrative distance value it's showing. All right, fine. and it's learned via the Ethernet 0/0. So those informations we're seeing, and also you can check with other commands related to OSPF, IP, OS route, OSPF. So this specific command, you'll be seeing the routes that's learnt specifically using OSPF. And there are other command to check OSPF topologies and databases and all, but that's fine. This is more than enough. Okay. All right. Now the main matter, we need to configure the OSPF in the Palo Alto Firewall, right? So let me log in, and what I'm going to do, again, just to avoid time consumption, in the last video when we configure RIP, that configuration is still available in my Palo Alto, right? So where I have configured this interface IP address, I have configured the loopback interfaces, and I have created a virtual router in Palo Alto. Within that virtual router, I have configured the RIP routing protocol. I'll show you. So landed in my dashboard. So I'll go to my networks. Under networks, if you see, last time we have already created zones. It's loading. Okay. Yeah. So last time we have already created zones, and means one zone, right? Inside zone, and all the three interfaces is like one physical interface, and two loopback interfaces are a part of the same zone. And we have configured with the required IP addresses as per our topology. If you go to the Ethernet, I can show you it's a layer 3 with the management profile ping, and this interface 1/1, this interface 1/1 is already configured with IP address 10.10.10.100/24, right? And also it is added with the virtual router as per the last session, right? So let me go to the virtual routers now. So if this is the virtual router we have created in our previous session, right? When we practice RIP. So I'll just click it. Okay, I'll show you. There is nothing in static. If you see RIP, so last time, if you remember, we have enabled RIP and we have added this interface, and also then when we learn about the secure authentication, right? We created an auth profile and we have added. So this is means in this router we have means basically in the virtual in the Palo Alto we have created a virtual router. Within that virtual router, in our previous video we configured RIP and used it, right? So as I said, just to avoid time consumption by creating the interfaces and zones and IP addresses again and again, what I'm going to do, I'll just within this virtual router, last time I have configured RIP, right? I'll just disable this WIP. Okay, I'll just disable this WIP and I'll enable the OSPF. Okay, or what I can do, I can delete, means it depends on you. If you want, you can delete this virtual router, you can create a new virtual router, and you can configure OSPF for it. Okay, so I'm just using the same virtual router. I'm opening it, but what I'm going to do, I'm just disabling this, means this is the command that's used to enable RIP, right? I'm just disabling it, and if you required, you can delete these interfaces here as well, or else you can also keep as it is, unless until you means if you disable it, then it's not a problem. But by keeping enable also, don't go with the other option. And one more thing, when you have one virtual router created and interfaces are added to it, even though if you create another virtual router and try to add the same interfaces, it will not get added, because we have already seen that interface can be part of only one virtual router, right? Fine. So what I do, I have disabled this, means earlier it was enabled, I just uncheck it to disable it. And in addition to it, in top of it, what I do, I just delete this authentication profile, and I also delete this interfaces that I have created. Okay, so now it's just a virtual router. Okay, it as per this topology, it's just a virtual router we have created in this Palo Alto. So now let's continue configuring OSPF within it. Okay, so in order to configure OSPF, there is an option called as OSPF here, right? If in case you are creating a new virtual router, just name a virtual router, make sure that your interfaces are added here by clicking the add button, then come here to OSPF by clicking here. As we did in RIP, what we need to do, we need to check this to enable. All right, click it. So once we click it, OSPF will be enabled. Okay, So this 777, this is the router ID that I have given in my previous lab sessions. Okay, you can give a router ID here. So as we discussed in our first slide, right, during the theoretical discussion, we have seen that router ID is like a name to the router, right? So you need to give any name here. So I'm just giving maybe the same 7.7.7.7. Okay, fine. So BFD not required. So area. Okay, so we have seen that OSPF uses the concept of area to manage, right? Create area. So in order to create area, by default there is no area here, right? Not even the default area. So we need to create it, but not even the default backbone area 0, right? So in order to create it, click the button add here. Okay, here we need to define the area ID. In the Cisco, we have just given the defined the area 0, right? We just mentioned as like area 0, but in Palo Alto we cannot put area simply like 0. Okay, see, even if you put, it will be highlighted in the red color saying that it's invalid. So instead what you need to put, you should put like 0.0.0.0. So this is how you need to define the area 0. All right, so now we have created area 0, and this is the type of what type of OSPF we need. Okay, you might be know about these types, right? The stub area, not so stub area, like that. So these are the type. So I'm just keeping like a normal. Okay, here this is the place where we need to advertise routes. Okay, either you can go with the IP ranges, or the simple way as we did in the RIP is to declare the interfaces that's connected. So what I'm going to do, I'm just going to declare the interfaces, this interface as well as this two loopback address. So as you know, we cannot means we can have the loopback address as a passive mode only. Okay, so but we can have this interface, right, this physical interface as the normal mode, which can send and receive the hello exchanges, hello packets. So I'll go here, I'll add interface. First I'll add the physical interface, that's 1/1, and it's enabled. Okay, once we click add, whatever interface that is we're adding, it is enabled. If you uncheck it, then it's not enabled. Okay, by default it's enabled. And if you want to keep it as a passive mode, you can check it, but as I said, I want to keep this interface as a normal mode, which want to send and receive the hello packets. So I'm not selecting the passive. And metric priority authentication profile means it's same as like how we created the authentication profile in the RIP. So we created a keychain, means we have created authentication profile, right, in the RIP in the last video, where we have created a profile, and within the profile we have given the password. So as same we can do in the OSPF as well. And once the authentication profile is created, we need to map it here. That's it, simple. Okay, that's it. So I just enable this interface and click, and these are the intervals. Okay, hello intervals will be sent every 10 seconds once, and dead counts is 4 times, and retransmission interval is 5 seconds. So these are the counters. All right, so I'll just click OK. Same, I need to configure or add the loopback interfaces. So again, I'm going to this option and I'll click loopback 5. Okay, but this time I need to make it as a passive mode, because it's in loopback, right? And if you want to have a broadcast, you can keep it broadcast, and if you want to have a P2P, P2MP, you can have it. Okay, it depends on your topology. So I'll just put OK. I'll create one more to add the loopback 6. I'm adding it again, make it as passive because it's a loopback. Just click it. That's it. So we have added the interfaces and click OK. So what we did, we within the means first we need to create the virtual router. If we already had a virtual router, we just get into the OSPF, means already RIP was running. We have deleted the RIP from the router, and we have enabled OSPF. We have given the router ID. Then we have created a area, and within this area we have added the interfaces, means we have declared what are all the interfaces want to be part of that area. Okay, that's it. Click OK. So the configuration from Palo Alto end is done. It's much simple. So once done, just click commit here. Okay, commit. So it will take few seconds. Let's wait. 55 seconds. 75. 8. All right. So it's successfully, the configurations are committed. Okay. I'll just close it. Okay, in order to confirm what we need to do, if you see here, right, so this is the topology and we have already configured the OSPF. So now if we go to any of the device, say for example, if we go to router 1, if we check the routing table, we'll be seeing this two routes, okay, that's learned through OSPF, and this route means 5555 and 666 also learned through OSPF. Okay, and we have already witnessed that when we check in router 1, it already learned the routes from router 2 once we configure the OSPF in router 2, right? So now we have configured the OSPF in Palo Alto. So if we go to any of the device, any this router 1 or router 2, we'll be seeing the network 5.5.5.5 as well as 6.6.6.6 in their routing table that was learned from OSPF routing protocol. As same, if we check the routing table of Palo Alto, we'll be seeing the 1.1.1.1 network, 11.11.11.11 network from learned from router 1 way from using OSPF, as well as this 22 network that is learned using the OSPF routing protocol from the router 2. All right, let's check that. First, let's check from the Palo Alto. This time maybe we'll check from GUI. So in order to check it, check the routing table. So this is our router, right? The virtual router that we have created. At the right side, we'll be seeing more runtime status. Just click it. So once you click it, you'll be seeing the routing table here. So if you see the routing table here, right? Maybe I'll enlarge it. So if you see the routing table, right, it's mentioned as like 1.1.1.1 network, which is the loopback network that's configured, loopback interface configured at router 1. Okay, this is configured in router 2, and again this 11 network configured in router 1, 22 network configured in router 2. If you come here, so this next hop and all we have already seen, right? So in order to reach this, it will go to this next hop, but we have not manually specified anything as like the static routing, right? It automatically learned. So in order to reach this destination, who should be my next hop? 10 10 10 1. So this information was automatically learned. Okay, how it learned? And it is telling that this is active, and how it learned, if you see, right, it's mentioned as like OI. Okay, OI stands for OSPF internal. Okay, okay, O stands for OSPF internal, intra area. Okay, so it means basically it learned using OSPF, right, within area. It's not from two different area, means we made everything as an area 0, right? So within area, using OSPF routing protocol, it learned this network. So this confirmations we are getting. And if you want to explicitly see the OSPF routing table, you can click this option, OSPF, and we can see more information about the OSPF here. This is the router ID we have configured, and the counters means this is a single area, right? So we don't have any area border or ASPR area border. Okay, go to area. So this is the area we have created. All right, and interfaces, these are the three interfaces that is part of our OSPF area, and as you know, these two loopbacks are very passive interfaces only. Okay, and neighbor, so these two are the neighbors. Okay, this 10.10.10.1 is router 1. Okay, this 10.10.10.2 is router 2. So OSPF automatically learned the neighbors. And if you see the router ID, right, the name of the means, as we said, OSPF uses the concept of router ID, means like a name. Okay, but if you remember, we have not specified any router IDs in the Cisco routers when we are configuring it, right? We just configure the interface IPs and we just configure OSPF, but we have not mentioned the router ID. There is an option where in this index, if you want, you can specifically mention, just like here, right? When you're configuring OSPF, you can mention router ID. Okay, you can configure router ID and define any router ID here. And if in case you have not configured, then by default OSPF will take the loopback interface as the router ID. And if you have a multiple loopback interfaces configured in the router, then the highest loopback will be considered as the router ID. If in case you don't have, you don't even have one loopback, okay, in that case, the physical interface, whichever is having a highest IP, is considered as the router ID. It's just a name kind of thing. Okay, so basically, this two are the neighbors. Means for Palo Alto, this router 1 and router 2 are the neighbors. Okay, that's what it is mentioned here. Okay, so virtual link, it's a different concept. Means it's a part of OSPF. As you know, if you have a multiple areas, okay, and if your area is not directly connected to area 0, then this virtual link will come. And when we configure area itself, there is an option to create a virtual link, right? So you can just enable it and you can define that. That's it. All right, so we can also cross verify that from router. Okay, I'll just go to my router. I'll just keep my this thing aside, so that would be better for understanding. Okay, I'll just click router 1. Okay, we'll check the router 1 routing table, show IP route OSPF, specifically OSPF. So if you see, right, already this two net in now I'm checking in this router 1. Okay, already this 2 network and 22 network are learnt when we were checking in the last time, right? If you see this time, this 5 network and 6 networks are learnt, which is coming from Palo Alto. Okay, if you want also, you can ping 5.5.5.5. See, we're getting response from Palo Alto. Ping 6.6.6.6. We're getting response. Same, if you can also check in router 2 if you want. Okay, I'll minimize it. This is router 2. Okay, I'll just put show IP route OSPF. If you see, last time it learned 1 network and 11 network, right? Once we configure OSPF here, but this time it also learned the Palo Alto networks using OSPF. Okay, so this is how we need to configure OSPF in Palo Alto, and we can manage OSPF. And as you know, we have practically seen OSPF is a dynamic routing protocol that will learn the route automatically.